This is the AP Chemistry Buffer problem set, problem 1D. This is probably one of the harder ones, so the expectation is that you've done 1A through C first. So this one's slightly harder because it says it's a mixture containing 0.1 molar propanoic acid as well as 0.1 molar sodium propanoate. So it's actually a common ion effect problem because I have this propanoate in the sodium propanoate, but I also have it in the propanoic acid. So it's in two places. So if I write my equation like normal, I put the propanoic acid in water, and it reaches some equilibrium with H3O plus because it's an acid and propanoate, not an ion. And if I look at my ice table, well, I start with 0.1 molar propanoic acid. That's pretty normal. But the new thing, which I really haven't dealt with before, is while I have 0 of the hydronium and water doesn't matter, I now already have some propanoate, which is 0.100 molar. How did I get that? Well, this comes from the NaC3H5O2 because this dissolves in water and separates. Na is just a spectator ion. It doesn't matter, but what does matter is this propanoate. So when I look at my change, obviously I have no H3O+, so my reaction has to shift to the right because I can't have a negative number over here. So minus x plus x plus x, 0.1 minus x, x, and 0.1 plus x. When I write my Ka, which I already know from problem number 1, it was given to me 1.3 times 10 to the negative fifth. Ka is H3O plus times propanoate, so I would get x times 0.1 plus x divided by the propanoic acid, so 0.1 minus x. Now I can ignore this plus and minus x, and I will check after just to make sure we're okay. But if I look at this 0.1 over 0.1, well, that's going to cancel, so I know that x is 1.3 times 10 to the negative fifth. So if I'm looking at this and trying to find the pH, I know my pH is a negative log of H3O+. And in this case, x is the same thing as my concentration of H3O+. So I'm going to take the negative log of this number, 1.3 times 10 to the negative fifth, and I'm going to get a pH of 4.89. Now, because this number x is so small, it's 10 to the negative fifth, that's going to be way less than 5% of 0.1, which is 10 to the negative 1. We're talking about an order of 4, which is a magnitude of 1,000. So I'm really not worried about the fact that I ignored these two x's. And this makes sense. This is definitely an acid, so it should have a pH less than 7, and a 4.89 pH seems to be logical.